Hello, this is Captain Chaudhari. In my series of videos on basic stability calculations, today I'm going to do a few numerical on finding out of BM transverse and BM longitudinal. In fact, one numerical where we will find BM transverse as well as BM longitudinal in case of a craft whose water plane area is curvilinear, like ship-shaped, right? So we are given information in terms of half ordinates, right? So we'll do this question. This question is from my book, Basic Complete Stability Calculations, right? Complete ship stability, right? So this particular numerical is about a ship that is 225 meters in length, because I have been given 10 ordinates. That means 9 segments. 10 ordinates means 9 segments, and each segment is of 25 meters, so 225 is the length of the water plane area. Half ordinates which are given are 6, 28.8, 35.8, 37.1, 37.3, 37, 34, 26.6, 14.5 and 0.4. Now these half ordinates may be given from forward, but we always tabulate them starting from aft. The idea is we have to find out LCF, and LCF is the distance of center of flotation from the aft ordinate. So what we get in the 5th and 6th column is like moment of area or moment of inertia with respect to the first ordinate. So if we have to find out the center of flotation with respect to the first ordinate, it should be the aft ordinate. So I have placed these half ordinates starting from the aft. Now if we have to find out BM longitudinal, which means that BM longitudinal means we are dealing with a ship that is pitching about a center of flotation athwartship axis through small angles, right? So the moment we talk about BM longitudinal, what should come to your mind is the vessel is pitching through small angles about an athwartship axis passing through the center of flotation, right? So we are talking about the first ordinate being aft ordinate, and that aft ordinate is perpendicular to the fore and aft line, right? So if our reference axis is an athwartship axis, right? Eventually we are going to find out the moment of inertia about an athwartship axis passing through the center of flotation. So our axis of reference, if it is athwartship, and the ordinates are also given athwartship, that means ordinates parallel to the reference axis. You understand what I'm saying? What I'm saying is, like, if we are given half ordinates and the reference axis over here, the axis parallel to the ordinate, so we need 6 columns. It's a 6-column format that we need to do to find out the BM longitudinal. So what is the 6-column format? The first column is ordinates, right? And the second column is Simpson's multiplier. Because there are 10 ordinates, that means 9 segments. 9 is divisible by 3, which means that I'm going to use the second rule, that is 1, 3, 3, 1. So 1, 3, 3, 2, 3, 3, 2, 3, 3, 1. So this becomes Simpson's multiplier. And the next column is y dx, that is the product of 1 into 2, 1 and 2. So it becomes 6, 28.8 into 3 gives me 86.4. 35.8 into 3 gives me 107.4. 74.2. 111.9. 111. 68. 79.8. 43.5 and 0.4. Next is lever. Lever is the distance from the first ordinate. The distance of first ordinate from the first ordinate is 0, of course. Then this is h, 2h, 3h, 4h, 5h, 6h, 7h, 8h, 9h. Next column is yx dx. That is the multiplication of third column with the fourth. From 0 here, 86.4h, 214.8h, 222.6h, 447.6h, 555h, 555h, then 408h, and 3.6h. So that is 86.4 plus 214.8 plus 222.6 plus 447.66. This gives me 2844.6. 2844.6h. Let me say this side. It is 6 plus 86.4 plus 104. Give me 688.6. The sixth column is y x square dx, which means that this column multiplied by the fourth column, that is x, so it is 0, and then 86.4 h square, and then it is 429.6 h square. This is 667.8 h square. So 90. Gives me 2775 h square. 2448 h square. 3910.2 h square into 8, 2784 h square gives me 32.4. Let's total it up. 86.4 plus 429. Now what is the half area? Half area is 3h by 8 into 688.6, that is the sum one. And moment of half area is 3h by 8 into 2844.6 into h. Now because I've got the moment of area about the half ordinate and I've got the area, although it is half, I've considered this as the moment of half area, and this is half area. If I divide this by this, what I will get is the position of center of rotation with respect to the half ordinate. So if I divide this expression by this part gets cancelled, and what I get is 103.274. 103.274. That is the LCF Now let me also find out what is the full area. The full area will be 2 times 3 into 25 divided by 8 into 688.6 meter square. So that is 150 into 688.6 equals divided by 8 gives me 12911.25. 12911.25 meter square. I write it here. The area, the total area is equal to 12911.25 meter square. So I've got the LCF and I've also got the area. Let me find out what is the moment of inertia, the total moment of inertia about the aft ordinate. Now moment of inertia about the first ordinate, that is the aft ordinate, is given by 3h by 8 into some 3, that is 14922.8 into h square, that is 25 square. This is the moment of inertia for the half side, and if I want the full side I'll have to multiply by 2, and this is 150 into gives me moment of inertia 1,748,7,6,5,6,2.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. You need to confirm how many digits for moment of inertia, because this is meter raised to 4. I'm not interested what is the digit after decimal, but at least number of digits you should confirm. Right, so 148,765,62 meter raised to 4. This is moment of inertia. If I want to find out what is the moment of inertia about the athwartship axis, I will have to do minus AD square. As I told you, moment of inertia is minimum about the centroid axis. So if you're talking about the athwartship axis, and that to athwartship axis passing through the centroid, the minimum should be through the center of flotation, and to get that moment of inertia I will have to do minus AD square, where A is the waterplane area. So the moment of inertia about, so if we draw the diagram, I've got moment of inertia about this axis. If I want moment of inertia about the athwartship axis, I will have to do moment of inertia over here minus AD square. So that would be 1,748,7,6,5,6,2. Once again 3, 6, 9 minus AD square. The total area is 12911.25 and the LCF is 103.274 square of that. So 103.274 into 103.2 into 12911.25 equals minus 174,8765,2 gives me 3717179. I can take 37171, 37171, 379. This is the moment of inertia about this axis, and this divide by moment of inertia divided by underwater volume. So displacement was 150,000, but since I need the underwater volume, I would write 150,000 divided by 1.025. So it becomes 37171,379 into 1.025 equals divided by 150,000 gives me 254.004. That is 254.004. So BM longitudinal is equal to 254.004 meters. So we've got the BM longitudinal for the ship as 254. You can see this is even longer than the ship's length. Sometimes the candidate gets confused. Oh, BML is longer than the ship. No, BML is in vertical direction. So 254.004. Now we have got BM longitude. Now BM transverse. BM transverse is all about rolling. I tell the candidates when the vessel is rolling, suppose this is water level, the center of buoyancy goes in a swing. Where is the imaginary swinging point? That is transverse metacenter, and the distance from B, vertical distance above B up to transverse metacenter, BMT, is given by moment of inertia of the waterplane area about the centerline axis divided by underwater volume. So this means that we are talking about a situation where the ordinates are this way and the reference axis is centerline. That means we are going to talk about a situation, right, whereby the ordinates are perpendicular to the reference axis. When the ordinates are perpendicular to the reference axis, it is actually a 5-column format in case you want to find out moment of area as well as moment of inertia. Now moment of area, if you see in the last part, moment of area we had found out because we wanted to find out what is the LCF. But here we have no doubt that with respect to port and starboard, the center of flotation has to be on the center line. So we don't need moment of area. So it will not be a 5-column format, it will be a 4-column format, right? We will straight away jump to moment of inertia column. We don't want moment of area column if we have to find out BM transverse. Now the thing is, the first 3 columns are common whether you're talking about the ordinates parallel to the reference axis or perpendicular to the reference axis. That means whether the axis is this way or the axis is this way, in both the situations the first 3 columns are same. So now the last column is for the moment of inertia, where the reference axis is perpendicular to the ordinates. The key for that, the symbol for that is integration y cube dx, right? Integration y cube dx. That means we have y dx here. If we multiply y dx with the first column, it becomes y square dx. And if we multiply the third column twice with the first column, it becomes y cube dx, because this is already y dx, right? So let us find out y cube dx now. So it will be 216. Then you have 28.84. That gives me 7166. 7166. 3.6. Now 7.4. That gives me 137648. 137648.1. Next is gives me 102129. 102129.6. Next is, that gives me 155685. 155685.3. Next is 151959. 151959. Next we have 8608. 78608. Then we have 8. That is 56463. 56463.3. Then we have 9145. 9145.9. 0.06, that is 0.1, I can round it up, 216 plus 7166 3.6 plus 1, it gives me 7635 18.9. Now first of all, let me find out what is the moment of inertia. This is just the sum 4. So 1 upon 3 is part of the process I told you last time, multiplied by 3h by 8, right? Multiplied by 7635 18.9. Now this is the moment of inertia about the center line, but for the half area, total moment of inertia I will have to multiply by 2, and this divided by underwater volume, that is 150,000 divided by 1.025. This will give me the BM transverse. So 2 into 3 into 25 by 150 gives me 32.608 meters, the BM transverse. So this is how, if the half ordinates are given in a question and we have to find out BM transverse and BM longitudinal, we first make the 6-column format for finding out BM longitudinal, and then we add one more column, that is integration y cube dx, right? We don't have to find out where is the position of center of flotation in athwartship direction. We know it is on the center line, so we don't have to involve y square dx column. So this is y cube dx column, and this was the moment of inertia. This would give moment of inertia of the half water plane area. Total water plane area multiplied by 2 divided by underwater volume will give me the BM transverse.